In today's session, we will explore the key factors driving productivity in blast furnace iron making. As we know, the quest for higher output, reduced coke rate, and stable operation continues to evolve. This presentation is industrial case study to highlight actionable improvements in burden preparation, which is the most important one. The We can say it is combined burden preparation and agglomeration and operational control. Now, before diving into optimization strategy, let us establish the benchmark that define blast furnace productivity. These include the coke rate per ton of hot metal, a specific productivity per unit hearth area, volume utilization per ton hot metal, and the efficiency of indirect reduction reflected in gas utilization ratio. These metrics guide furnace operators in balancing throughput with energy efficiency, and which is supposed to be one of the biggest role, that is producing with the energy efficiency. In this segment, we will see how the burden preparation, what is the role of burden preparation. As each one of us know, burden preparation plays a pivotal role in improving furnace permeability and thermal balance. Screening and sizing the ore into narrow fraction and charging them in layers can significantly reduce pressure drop and enhance indirect reduction. That means if we have a two side segment, it is better to separate them and charge it rather than mixing together, and by that making a mixed layer of variable size. For instance, in Rock and Ougree works, output improve up by 65% simply by moving from mix to layer burden structure. The logic is very clear. Better gas flow means better reduction kinetics. Now coming to sintering part, which is supposed to be a lifeline for boosting productivity. The transition from ruble to sinter, especially flux sinter, has revolutionized burden consistency. Not only does it offer better physical strength and porosity, but also allow for higher blast temperatures and narrower shafting zone. In uh, one of our plant, it shows the coke saving reached around in quantity of around 60 kg per ton hot metal, while output jumped nearly 30% with rescreened center charging. The influence of center basicity is quantifiable using equation that correlate it with coke rate and volume utilization, as it shows it already gives a indication how productivity, our output and coke rate is depend. Now coming to the power of pelletizing. Pellet offers superior gas solid contact, especially when fines are eliminated and swelling is controlled. At Armco Middletown plant, iron production doubled over 7 years with increased pellet uses. The key is using hard strength pellet is screened to avoid clogging. Still, we must balance pellet use with sinter to manage swelling tendencies and also, which is most important, to maintain the void edge also. Mixed charging like acid pellets plus high basicity sinter is often optimal. So, while using pellet with the sinter, a very judicious decision must have to incorporate in order to have a maximum output. Coke size and strength optimization has a tremendous role in restoring productivity on long run. Coke mechanical integrity and size distribution directly impact gas permeability and raceway behavior. Ideally, coke size should be 3 to 5 times that of ore for maximum effectiveness in dry and wet zone. At one of the plant, simply reducing average coke size from 58 to 48 mm improved output by 8%. Moreover, classifying both ore and coke into tighter fraction reduces fluctuation and flooding risk. Now coming to the integrated impact of all these improvements. Here a coke rate, productivity and flue dust all has been taken into consideration to estimate the improvement ranges. When these interventions like burden sizing, agglomeration, fluxing, coke classification are implemented in synchronization manner, the benefit multiply. Coke rate reduction as it is shown 15 to 27%, output increase up to 100% and flue dust suppression all contribute to a stable energy efficient operation. This systematic approach is the backbone of modern productivity strategy. So, in conclusion, we can say that we have seen that productivity enhancements are not about one silver bullet. They are about crafting a burden that optimizes for gas flow, reduction kinetics, and thermal control. So it is blend of all these activities and hence flux center, well-sized palette, and layered of charging strategies when tailored to your specific furnace design offer game-changing results in cost and throughput. So we can say that operators do tomorrow to start making improvements. First, screen center and palette just before charging. Next, match ore and coke sizes for permeability. Use layered charging to avoid intermixing. And finally, track CO, CO2 and top gas temperature to guide your process adjustment. The data is there, let it drive your productivity. Thank you.